The 10th question says, if three lines whose equations are y is equal to m1x plus c1, y equals m2x plus c2 and y equals m3x plus c3 are concurrent. Okay, if these three lines are concurrent, concurrency means, okay, these lines intersect at one particular point. Then show that m1 times c2 minus c3 plus m2 times c3 minus c1 plus m3 times c1 minus c2 is equal to 0. Now, how do we deal with this one? How do we deal with this one? If three lines whose equations are this are concurrent. So concurrency implies that point of intersection of any two lines will lie on the third line. That's the aim and that's the way in which we'll be approaching this question. Although for those students who are aware of something called determinants, you will be able to solve this question maybe more directly. What you can do is simply write the coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3, create a determinant, 3 by 3 determinant equals equated to 0. You will get that condition directly. But here I am assuming that since we are discussing 11th and we have only studied, you have only studied 11th, so we will be solving this question from the basic concepts, right? That is, we'll solve 1 and 2, get the point of intersection and then satisfy that point on this third line. A similar thing which we did in the 9th question, right? Okay, so let's solve these two equations. Okay, eliminating y is pretty simple, right? What we can do is solving 1 and 2. Where does that take me? So what I can do is simply subtract, and that tells me 0 equals m1 minus m2 x plus c1 minus c2. This tells me x will be equal to c1 minus c2 with a minus upon m1 minus m2. This is the value of x that we have, right? Once you have x, can you also find y? Yes, y can be found by any of these equations that matter. Therefore, 1 will imply y equals m1 x is this, minus c1 minus c2 upon m1 minus m2 plus c1. This is y. Okay, and let's solve for y further, which gives me y equals, this is minus m1 c1 plus m1 c2, okay, and plus m1 c1 by taking the LCM minus m2 c1 upon m1 minus m2. Do you observe that m1 c1 will get cancelled over here, right? And m1 c2 minus m2 c1 will remain. This tells me y is equal to m1 c2 minus m2 c1 upon m1 minus m2 remains. This is the value of y. Okay, we have found x and we have found y, that is the point of intersection of 1 and 2. Using these 2 points, can we substitute these points in third equation? Therefore, third equation will give me m1 c2 minus m2 c1 upon m1 minus m2 is equal to m3 times x. X is minus of c1 minus c2 upon m1 minus m2, okay, and plus c3 simply, okay, multiply by m1 minus m2. In the denominator you have m1 minus m2, let's multiply by that. So you get m1 c2 minus m2 c1 minus is equal to minus m3 c1 plus m3 c2 plus. You get m1 c3 minus m2 c3. This is what you get. Please note this, observe this carefully, right? This is what you get. This was a complete expression, right? And we have to rearrange this expression in this particular form. So let's bring terms of m1, m2 and m3 together. So we have m1 c2 and we have m1 c3. This becomes m1 times c2 minus c3 in the LHS. Okay. Then you have m2 c1 over here, you have m2 c3 over here. This becomes m2 c3 minus m2 c1. So plus m2 times c3 minus c1. Okay. Then you have m3 c1 plus and minus m3 c2. Right. So plus m3 times c1 minus c2 is what I'll get over here. This is equal to 0. That's what I get. Please observe this carefully. M1 times C2 minus C3 plus M2 times C3 minus C1 plus M3 times C1 minus C2 equals 0 is the expression that I'm getting. If these three lines are concurrent, that is they pass through the same point, then this is what we wanted to prove, and yes, that's the complete solution of this 10th question as you can see over here.